Oh, right. All right. So we're moving on. We had our first lab. Again, Unix is fun. Lots of really cool things we can do with it. We're never going to touch it again. In other courses, you can do more stuff in Unix. The command line is useful. You'll want to get familiar with it, but we just don't really have the time to spend focusing on this class here. So we did the lab and we have fun. We'll move on to other stuff. So now we're picking up object-oriented programming. Today should be mostly review from last semester. On Thursday, we'll get into the new stuff, and then we'll talk about our first programming project. It'll be based on object-oriented programming and inheritance. So kind of a soft ease into it if you had me last semester, and if you didn't, then hopefully it's a good easy start as well before we get into some of the harder stuff. So we do skip over chapter 3 in the text. You'll notice it's not all that interesting, and it's all about algorithm analysis and how we measure things. So we'll start talking about that when we get into some of these things, but we don't need to spend a lot of time on a whole chapter about it. We can move right into recursion and then move into some of our sequences and specific data structures. Again, through about the midterm or so, up through winter break, we hit all these things pretty deep. We don't do everything with trees. You'll come back and finish up trees again later. We start with the basics of trees. We'll do priority queues, the basics of priority queues. We'll do our own maps, some basic hash tables. We'll talk about skip lists. We don't use them. That's more of an advanced topic. We'll look at search trees, again, at a basic level. We'll look at some basic sorting and selection, and we'll talk about ethics. So the second half will be a little bit more open-ended. We'll have a little more time for that final project we'll be working on, which should be a lot of fun. We'll see. I thought last semester's final project was fun too, and not everyone agreed. So, you know, there's that. Hopefully you like games. These games are fun. All right, cool. So I got PyCharm here. Let me start up a new project. I'll try and put everything into weekly folders. So this will be week 2, object-oriented, and we can go from here. Maybe. There it is. Okay. All right. And we don't need any of the basic starter stuff. So I'm a fan of using files and modules. That probably comes from my other object-oriented programming languages. I started way back when, and Java has a rule, there's one class per file, which can get a little tedious here, but I sort of like that it separates things. And then our history in GitHub is going to look really nice because anytime that class has changed, that file will have changed. Rather than I make one big module that has everything in it and 1,000 lines of code, that file is going to change every time I change something. So it's really just a stylistic preference here. There's not really a right way to do these sorts of things, but I'm going to add a new file here. Did we do our basic shapes last semester? I'm really fuzzy at the moment. So to be honest, I spent the weekend at the hospital, so I'm a little out of it today, but feeling mostly better. We'll get there. Just a little low energy, so I've not had enough coffee. And they told me I have to drink less coffee, which is really sad. But we'll see. I'm seeing the doctor next Tuesday before class, so that should be a lot of fun. So shapes, do we do like polygons and rectangles and squares and things? No, okay, well, cool. This is good then. So I'm going to make a polygon Python file here. PyCharm knows how Git works. Any good IDE knows how Git works because Git is the most widely used source control tool. Again, I don't usually use their integrations when I teach because the GitHub desktop client is the one I use because that's the same no matter what language I'm teaching. It makes my life easier. So if you like using it, great. You can use all the Git tools built in here. You can log in. That's all perfectly fine. I almost always skip it because that's okay. A couple of people noticed last semester things show up in red initially if they're not committed to GitHub. So they're like, why are my files red and yours are green? Well, they're red till we commit them. So once I commit my file here, and I open up my GitHub desktop tool, and let's do 2001, go to, so again, all these other files, perfectly fine, just let them go. We care about the py files. Those are the important ones. The other ones are for PyCharms. We know they're project files. We'll say week 2 started. I'll commit and push. Now when I come back here, in just a minute, they change colors. Right, now they're not red anymore. Okay, they're white. And then as we change them, I think they'll change colors again as we start. Yeah, they turn blue until we commit. So there's some visual cues the tool gives you to let you know you're working on stuff. But it's all just helpful things. It's not going to hurt anything that they show up in red. So for Polygon, we're going to have our class for Polygon. Now, Polygon is just a class. It doesn't inherit from anything. It's just its own standalone class. A couple things Polygon knows about itself. So we'll make our init method here. When you create a polygon, you probably need to know how many sides it has. So I'm going to take an argument here for a number of sides. So I will make a self attribute here, an instance attribute. So every instance of polygon will have its own value for number of sides. So I can make 50 different polygons a number. Some of them will be 4-sided polygons, some will be 2-sided. I guess you can't have 2, sorry. Told you I'm out of it. Multiple-sided polygons. They can all be different. Hector, my friend, thank you so much for donating those bits to the Student Scholarship Fund, the University of Michigan Dearborn College of Engineering and Computer Science. And my friend, the Reluctant Hermit, thanks for hanging out with us. Good to see you. So for a number of sides, if we want to save this value, I want a self.dot attribute so that each instance of polygon gets its own value. By convention in Python, we use this underscore to say this is a private value. Please don't go touch it. Python's trusty. It'll let you go change it if you want, but you're shooting yourself in the foot. You shouldn't change private values. It's just a convention here. So I'll have a number of sides is equal to the number of sides argument here. So you tell me how many sides are in the polygon. I'm going to set it here. What this lets me do is have this attribute and have control over it. Now, if I want you to be able to change it, I'm going to give you a way to change this value. I might give you a set method to set the number of sides. Generally, once a polygon has a certain number of sides, it's probably not going to change. So in our case, I don't want to give you a set method to change it. We want to say this is an immutable value or a read-only value. You tell me how many sides your polygon has, and then it never changes because it needs to know how many sides it has, and it shouldn't change. Once you have a 4-sided rectangle, it'll always be a 4-sided rectangle. So it just depends on what we're doing with our classes here, how that's going to work for us. But if it's a private value, we need to give them a public function to get that value out. So usually we have set methods and get methods, right? Setters and getters, or accessors and mutators, or there's all sorts of terms for them here. I like set and get because they're easy. So I'm going to define a get number of sides function here, and it's just going to return my self.number of sides. So you can, remember the down there. So you can get that value back out. So you can make a polygon with a set number of sides. You can find out how many sides it has, but we can't go change the number of sides directly. Right? We want it to stay fixed. We want it to be essentially read-only at this point. Now, other things that Polygon can do. Now, we don't know necessarily what kind of polygons these are. We don't have a lot of sort of things, but we probably need a way to set the length of the sides. So I also need a place to store side lengths here. So that's just going to be a list. And now I'm going to have some number of values here, right, in my list. Because as many sides as I have, I'll have that many side lengths. So I can say, hey, side 1 is a length 7, side 2 is length 13, side 3 is whatever, however that happens to be here. So these are going to be numeric values. So I probably want 0 in my list, and I want that the number of sides times. So that I'll have that many number of side zeros to start. Because I don't know, you haven't told me yet, but I'll have a place to store those values. So this is just a little shorthand notation. I'll make a list of this many zeros. Here, I think this is the right syntax here. I always get confused with these, and I try them, but this should work for us here. So this should set up a list of values, all zeros, with the number of sides, number of values. So then I want a way to set a side length. So I'm going to say set side length as a function here. Now I need some information. I need to know the side index. So which side are you telling me? Side number 0, right? Because we're 0 based, because everything starts with 0 with our list. Is it side 0, side 1, side 2, side 3, side n, whatever, and then how long is it here, right? So you tell me the index and you tell me the length. So I need 2 arguments here to work on these, and I'll set my self dot side lengths at the side index equal to the value of length. So go find that location in my list of side lengths and set the value. Okay, you told me here this side is length 4, this side is length 5, this side is length 6. Great, we'll just accept it. It doesn't necessarily have to be a closed shape. It doesn't have to make sense. We're not doing any sort of mathematical verification here. We're just going to let you give me values and we'll take them. Okay? So assuming they've set the length and done the right thing here, we should now also be able to have a method for get perimeter. Perimeter. The perimeter is just the sum of my self side lengths. Right? We have this built-in function for sum. If you have a numeric list, you can sum it for us. We don't need to do our own loops or anything. Just it's out of the box. We'll just sum that for us. That is the perimeter of our shape. It should be the sum of our lengths, our side lengths. Cool. So we can do these things for a polygon. Now, if I want to go use polygon back in my other file here, I'm going to import polygon. Now, remember, we have 2 different ways to import. There's the generic import, which imports everything. But then if I want to use polygon, I have to say I want polygon module.polygon class here. That feels like a lot of typing. And the way that I name things, my module names are really the class names. So then I have like a double name here and I feel bad about myself. So I prefer the other imports when I do my own stuff. This is just a stylistic preference here. So I'm going to say from polygon, import polygon. So from the polygon module, import the polygon class. And now if I want to use polygon, it knows I'm already using the module. I can just say I want it. So this will be my square equals a polygon of 4 sides. Right? So I can use that syntax instead of polygon.polygon to say polygon module, polygon class. Just a little bit of savings here for typing. So just a style preference. So now I have a square, so I can say square dot, and I get all those public functions I wrote. I have a set side length, I have a get perimeter, and I have a get number of sides. The number of sides should be 4, right? The get perimeter should be 0 because we haven't set anything yet, and then I can set side length. So I need to set 4 lengths here, and if they're a square, they're all the same. So I might as well just do a quick little loop here, right? For side in range 4, we're going to take square dot set side length given the side, right? Which could give me 0, 1, 2, and 3, which should be the right indexes here for that list because we have a list of length 4, and we want to set it. We'll just say this is a 10 by 10 by 10 by 10. It's a square, right? They're all the same here. And then when we're done, we're going to print my square dot get perimeter. It should be 40 if we did this right. Now again, I'm doing poor man's testing. Like I'm expecting to see something on the screen, and we're going to look at it and visually compare. Did I get what I expected? This is not a good way to test things because we're bad at this, but it's the cheap and easy way to do it here. Let me give it a run, and we get 40. So it seems like it worked okay. And again, if I want to run this in debug mode, put a breakpoint in instead of right-clicking run, I'm going to right-click debug, and I can watch this stuff run. You want to get familiar with the debugger. You're going to need it this semester as we start looking at data structures, looking at how data is stored in memory here. So I paused at line 3. I want to step into my code because I want to see what's happening in Polygon. I want to look at this init method here. So my step into here takes me to the init method. And I can see, okay, look, the number of sides was 4, right? And we can run that one. We can set my side lengths. So self is the current polygon we're creating here. And then it says, hey, you've got these protected attributes. Yeah, good. Oh, sorry, step 1 too far. Here's my polygon. Square. There it is. Now I have my square. So square is the instance of polygon. This is the location in memory. Right? This is the default thing we get when we see it here. It's protected attribute. It says number of sides and it has side length. So you can see the value. It's a little small here. I'm sorry, but you can see I have 0, 0, 0, 0 for my side lengths. Fantastic. So as I start doing my loop here, we should see those change. Now I have 10, 0, 0, 0, and I'll have 10, 10, 0, 0, 10, 10, 10, 0, and 10, 10, 10, 10. So we've successfully set all the side lengths here. We're going to get perimeter. Right? If I step into, now the self is the current polygon. We've called it square over here in main. That name goes away because we don't know what it is. All we know is self here inside the polygon code because we gave it, hey, here's the current polygon. This is where it is in memory here. And this is why that self attribute here is so useful. That's the current instance that we're working with. And I can see, hey, here's my number of sides, here's all that. We'll go return that value here, and we can print it back out. So I can make more polygons if I want. I can have a triangle equals a polygon of size 3, and then we'll say triangle dot set side length. We'll do 0. And what is it? There's like a 3, 4, 5 triangle, I think is a good right angle triangle. I'm bad at math. It's been, if you don't use it, you kind of lose it here. So I think that makes a nice little right angle triangle, 3, 4, 5, right? And we can do the same sort of thing. And if we want to, we could print our triangle, get perimeter here, which should be 12, right? Cool. Not very interesting. Now, if we wanted to do other things with Polygon, we could add other attributes here. So instead of just number of sides, maybe we also take, how about a name? And we could default name to an empty string. So if you don't give me a name, I'll just let it be blank. I don't really care. So then I can say self.name equals name. Now, making this a private attribute is a little bit silly at this point because we don't care what name is. I don't care what you do with name. So in terms of whether or not this should be private or public, it doesn't matter because I'm not going to restrict you. There's no rule around what you can name a polygon. You can call it an apple. I don't care. It doesn't hurt my polygon at all. None of our code functionally depends on it here. So in terms of whether or not I should make it private and have public get and set methods, there's no use in that here. So if we don't want someone to have access to set, or we want to put rules around what is a valid value for setting, like, hey, you can only have a positive value here, great, we could do that. And maybe that's a good thing to have in here. When we set the side length should probably be positive. That's probably a good thing to check, right? We can say, hey, if my length is less than or equal to 0, how about we throw, or we want to raise an invalid, was an argument error, a value error. We can say length must be greater than 0. So these are exceptions. We talked about these last semester, right? Exceptions? Okay, good. So exceptions are ways for a class to communicate back to the caller that they did a bad thing. What you don't want to do is have print statements in your class code because there's no guarantee anyone is ever looking at the console. You don't know how your class is being used. It might be used in a web application. It might be used in a mobile application. It might be used in a console-based application. It might be used automatically where no one is actually at the computer. Right? It's just code is running behind the scenes every hour or whatever we want it to schedule this to do. So you can't have prints in a class command. It's just no one cares. They're not going to look at it. So exceptions are the way of communicating that if something really bad happened, it forces them to deal with it. They have to either handle it or they crash, and then they're going to feel bad because their program crashed. So if you give me a bad length, we'll just crash. So same way, if we cared about name and you had to have something for name, you could only be a certain type of name, or name's kind of a rough example here, but that's fine. And we can put rules and constraints around what is valid here. So now we have name. So I can say, hey, this one is a square, and this one here is a triangle, right? And then this get perimeter and printing it out is all well and good here, but I could have my own function for, how about we say print polygon perimeter that takes a polygon argument here. So I'm going to write my own function that takes a polygon, an instance of the polygon class here, and we're going to print the polygon.name. Right? We'll just get the name attribute here, right? And then we can say has a perimeter of, and sorry, we should do these as formatted strings because that's the right way to do this. Has a perimeter of polygon.getPerimeter. And end our quote. There we go. I can't spell anything, friends. Okay. So I have my own little helper function now. Instead of printing these out here, I can just call that given my square or given my triangle. Right? Just our own little helper code, because this code here we know does something with the console. So I can use the console. I can print stuff out. I can get inputs if I want. I can ask you, hey, what kind of shape do you want to make? How many sides does it have? Right? We can do all those sorts of things here. So we could make our own if we wanted. Well, let's run this one first, and then we'll make our own. Right? We see square is a perimeter, triangle is a perimeter. Fantastic. And if we want to make our own, we can ask them. So how about number of sides? Will be an int of an input. How many sides does your polygon have? And then how about we have a name as an input of what name of your polygon, and then we can make a polygon. So how about, I don't know, users polygon equals a polygon, given the number of sides and given the name. And then we can loop through. We can say for side in range number of sides. We need to get the side length here, so the length will be an int of an input. Could even be a float value. I don't know if these have to be ints, but I'm just using ints because that's easy here. Yeah. So I just right-clicked over in my project and said I want a new Python file. And I add a new file to a new Python file to our project. Yep. So int of an input of enter the length of side, and that's a formatted string. Side. Sure. And then we can take the user's polygon and we want to call set side length given the side to the length that we just got. We'll set them all, and then when we're done, we can print the user's polygon. I'm sorry, we want to print polygon perimeter given the user's polygon. Okay, so we should be able to ask them. Now this will interact with the user. So how many sides does our polygon have? 7 sides. All right. What's the name of our polygon? A septagon or something? Septagon? Sure. What's the length of side 0? 2? Side 1? 3? 4? We guess 5? 6? 7? 8? All right. Is that a perimeter of 35? It probably is, right? 15 plus 11 is 26 plus 7 plus 2. That sounds right. Look at that. Python can do arithmetic. Cool. So now we can make polygons. So we have a class. We have public functions that we can interact with. We can use them. If we give it bad length, things will crash. We didn't bother with try excepts because we could get to that later if we wanted to, right? If we gave it an invalid value, it would have crashed on us. We would have felt bad. So, okay, why don't we add that in? So it's a little rough to do in this loop here because it's going to keep iterating over our side length, and we're going to be stuck at 0. So this gets a little awkward for handling here, but it's doable. So we want, what do we want to do here? So when we call it here, we're going to try calling set side length, and then except for value error, as error or something, or print the error, and then we're going to ask them again. So this sort of has to happen in a loop here then. So we can say, now while true is usually an ugly loop and I don't like these, but it's workable here. So I'll actually move that in, why not? So if it works here, we can break the loop. If it doesn't work, we'll print the error and we'll just keep on going. Once we break the loop here, then we can go to the next side here. Does this make sense? I don't want to skip over too much, but hopefully we've seen this sort of stuff before here. The other thing you can do, if you don't like these while trues, you could say successful is false, and while not successful, we can keep on going. Instead of break them, we could say successful equals true. Some people prefer this sort of syntax instead of a while true, just because depending on when you learn to program and how much people beat it into you, a while true just feels really bad sometimes. Not that anyone really cares, but it does the exact same thing with a break. So either syntax, perfectly fine. I don't care, whatever you prefer. Doesn't matter one way or the other. But now we should be able to run this here, and if I give it an invalid value, so we did size 7, our polygon is a septagon. Here we said -1, length must be greater than 0, and it's repeating length of side 0. So it seems to be successful here. If I give it 0, it has to be greater than 0. Okay, cool. So we can do a bunch of length 1s if we want here. And life is good. So we're handling that in this part of the code here. Now, again, we spent a little bit of time last semester reading files. So if I were to read a file with some polygon data in it, right, some sort of process somewhere, pretend we're a manufacturing facility, I don't know what, and they give us a file with the specification for a polygon, we could go read it out of the file. If I get an invalid value out of the file, probably just need to crash, right? I'm not going to re-prompt the user anything here. I need to probably do something with the file, spit it out somewhere, put it in an error queue for someone to look at and be like, hey, I can't process this file because they gave us bad data in it. it needs some sort of other type of intervention here that's not, let's just ask the user again, right? It all kind of depends on the workflow of what we're doing with our data. So this is one way. Pretty much everything we do deals with user input because there's not a whole lot of other things for us to do at this point in time. Later on, hopefully we'll get into doing some web services, which are a lot of fun. We can get some data off the web and actually work with some live data, which should be pretty cool, but I got to make sure that API still works. And they like, some people like to give away stuff for free, and then as soon as it becomes popular, like, haha, now you have to pay us for it. Which I get, like people need to make money, but then when we don't have the free thing anymore, I can't do the cool stuff, which is sad. So we'll find something. Anyway, so that's a polygon. So thinking about object-oriented programming and inheritance, this idea that I want to make a special version of Polygon that is a polygon, but does something special, does something unique here. And I don't want to have to reinvent the wheel. Not that Polygon does a whole bunch of stuff here, but it's a nice basic example for us that it does some things already. I don't want to have to redo it here. So I'm going to make another class here. We'll call this a, let's do triangle here. And we're going to say this is a class triangle, and it inherits from polygon. So it doesn't know what a polygon is, that's fine. So we need to say from polygon, import polygon. Okay, now I can inherit from polygon. So triangle is a polygon. Now triangle, when we init a triangle here, you don't have to tell me how many sides a triangle has. I know how many sides a triangle has, right? It has 3 because it's a triangle. So I don't need an argument for that, but what I do need to do is I need to call the polygon init method so that the rest of this happens. And I probably also want that name option here. So maybe we'll take a name. We can say name equals here. So we're going to take our superclass super init. A couple ways of doing that. I think the super init is probably more popular. You can also say polygon.init. This, and then you have to pass self, which is a little funky here. So I prefer not using that one usually. The super init's a little bit nicer here. Say, hey, go to my superclass. This inheritance is a superclass and subclass, or parent class and child class, or base class and derived class. I don't know why we have so many terms for these things. They drive me nuts. Here, but we're going to init. We're going to give it 3 for number of sides, and then the name argument, right? Because I have 3 sides always as a triangle, and then whatever name you told me I am, sure, we'll pass that on. Okay, and then we can init. So this is how you make a triangle. For set side length, works perfectly fine, no worries here. But other things triangle can do then, we can define a get area here. So to get the area, that's 1/2 base times height. Now I forget how you figure those out here if they're not right angle triangles. There's math for it here, right? I don't remember what the math is, I'm sorry. It's not really that important at this point here, but oh, you know, we never got a get side length. I should have done that. We need a way to get the side length out here, given a side index. Return our self side lengths at the side index. Right, so this way you can get an individual length back out here. So you set the lengths, we can get the lengths. So for triangle then, we're going to return 0.5 times self dot get side length of 0 times self dot get side length of 1. I'm just going to leave a note here. This is bad. I'm sorry. Right, there's a, all right, now I'm feeling really bad here. Area of a triangle. I can't spell, and I know base times height. But what if we don't know what the height is? That's a right angle triangle, sure. Isn't there a generic, this one is it, right? Oh, I just had it, This was the formula. This one, right? Stop. Yes. The semi-perimeter. Perimeter divided by 2. Does this ring any bells? Have you guys done math? It's been so many years since we've done math here. This is probably right. Okay, well, let's do this here because we're going to do the right thing here. And I'm going to find this source here. Okay, so our formula then is the square root of the semi-perimeter times the semi-perimeter minus A times the semi-perimeter minus B times the semi-perimeter minus C. Sure, that sounds like fun. So we're going to return And we can do this all in one line if we want here, right? So this is my math dot square root of the half the perimeter, right? So I guess we want to define our semi-perimeter. There is self.get perimeter divided by 2. We'll save that nicely here, right? And if you want to call it S, that's okay. Again, I don't like short names because I'm going to forget what S even means as soon as I'm done with this. So sure. So we have that times that minus my self.get side length of 0, right? And we just keep on multiplying, right? Side length of 1 and side length of 2. All of that, right? But now, order of operations, right? Because we need to make sure the arithmetic happens first on each of these. And force some order of operations to happen here. So do the semi-perimeter minus each of these, then multiply them all together, then take the square root of that. I love who figured this out? I don't even know. Like, probably someone like back in BC time, right? Heron's formula. Oh, I am a little out of it. Yeah, Heron. Who is Heron? Heron. A Greek mathematician. How old is he? Where do we go to our Wikipedia page? When did it have like his? Okay, 60. Okay, it was not BC. I apologize. So within the last 2 millennia, we figured out how to find the area of triangles. Sure. He made a steam-powered device back in 60 AD. All right, I'm sorry. Anyway, so we can get the area here of a triangle. Yay. So if I were to make triangles then, right, like this one here, we know is a triangle, so I can use triangle instead. We'll just call it a triangle. So I need to import triangle, so from triangle, import triangle. Now printing my polygon perimeter is still going to work here because a triangle is a polygon. Still tells me what the perimeter is here. All these things still work. I still have all those public functions, but then I can also then with my triangle print the area of the triangle is, do that as a formatted string, triangle.get area. Now I have a get area function because it is a triangle here. Right? We can get the triangle area. So what is the area of our 3, 4, 5? 6, 1/2 base height, right? If base was 3, height was 4, right? Half of 12, 6. Look at that, it checks out. The formula works. You guys don't look impressed that the formula worked. A 2,000-year-old formula works. Okay, we get triangle. Super fun. We okay so far? All right, next one. Let's make another class here. Let's make a rectangle. So similar to a triangle here. So we're going to, from polygon, import polygon. It knows how many sides it has. So our class rectangle is a type of polygon here. We'll define our init method. And again, we'll take a name here, just in case you like to name these things. We're going to call our superclass, super init, given 4 sides and a name here. We can also get area of a rectangle here. Now, rectangle is length times width. So probably side 1 times side 2. So self.get side length of 0 times self.get side length of 1. Now, but what happens if I do a bad thing with my rectangle? And I go in here, my main class, and let's go make a rectangle. Too many spaces. So from rectangle, import rectangle. Did I not finish it here? I think I finished it. Yes, it does. Thank you. Super init. I tried the type ahead. Usually that works for me. Okay. So if we make a rectangle here, rectangle equals a rectangle, small rectangle, and then I say rectangle dot set side length of 0 is 5, set side length of 1, 2, and 3, and let's say this is like 6, 7, and 8. Do I have a rectangle? No. So we've let a bad thing happen. because set side length lets us do that in Polygon. So what we need to do is we need to change the behavior of set side length, right? So we are going to override what my parent class does and say, please don't do this anymore because you'll do a bad thing. So we're going to make another method here called set side length, given the side index and the length here. We're going to say, hey, if my side index, how about modulus 2? Now, a lot of people here like shorthand because Python developers don't like typing a bunch of things here. So remember, Python is truthy. Everything in Python is true or false. So any number that's not 0 is true. So saying side index mod 2 is saying if the remainder is not 0, this will be true. So if the remainder is not 0, it must be side 1 or side 3 or 5, 7, some odd number here, right? I mean, I only have 4 sides, but we don't really care. We could check for that, right? We could say, hey, if my side index is greater than or equal to 4, raise a value error, invalid side index here. That sort of thing. Sure, perfectly fine. Now, this is probably going to crash anyway when they go and try and set the side length here because there won't be a value there in the list here. So this is sort of redundant at this point. We don't really need to have it here because when I make my list of side lengths here, there's only 4 of them. So if you try and say, hey, side index 5, set a value, it'll crash anyway. So it's kind of silly to have that in here. It doesn't hurt anything, but we don't really need it. So anyway, this will be for odd numbers here. So this is odd sides here. We're going to say super.set side length, side 1 to the length, and side 3 to the length. So if you set 1 or 3, I'll set them both for you, right? Because I need to make sure that I maintain the integrity of my rectangular object. If you want to set a 1 or 3, they're both going to change because it needs to stay a rectangle, right? Otherwise, my else case here will just set the side lengths of 0 and 2 to the length. So if it's an odd number, set 1 and 3. If it's not an odd number, it must be an even number, set 0 and 2. So you can try and say, hey, sure, let's set it to 5, 6, 7, 8. What we're going to get is 7 and 8, right? Because 2 will set 0 and 2, and 3 will set 1 and 3 for me. So this code works here. It might not do exactly what I expect, but I'm setting a rectangle. So it's a little bit funky here on how we would tell the user to expect this to happen, but it's just sort of what we're working with. So now I can set the side lengths, and then I can print the area, print my rectangle area. Area of a rectangle is rectangle.getArea. Sure, and it should be 7 times 8, right? It would be 56 if we did this right. Let's see. One side, one, sure, 56. So the area of our rectangle seemed to work, right? It took the 7 and the 8 here, so this sets 0 and 2, that's 1 and 3, right? Just so we know what's happening behind the scenes. Does that make sense? Cool, so we've overridden the behavior here with our rectangle class. Okay so far? All right, what if we wanted to go further? What if I wanted to make another special class here? How about we make a square class? And then we'll say from rectangle, import rectangle, and we'll define our class for square. And a square is a polygon, but it also is a rectangle. So I can inherit right from rectangle here instead of polygon, which is fine. So then we can define our init method here. Again, take a name if you want, default it. We can call our superclass init. Now, the rectangle init method doesn't need the number of sides. All it needs is the name, right? It's going to hand 4 to polygon, so I don't even have to deal with the number of sides here. I just have to deal with name here. And then I need to have a get set side length method here that no matter what side index you give me, I'm going to set them both. So I'm going to call my superclass set side length of 0 in the length and 1 of the length. Because if you change any of the lengths of square, they all change, right? It looks like it'll let you change any of the 4 if you want, but we're only going to change 1 of them, right? So I'm going to do both of these things here in my rectangle superclass, which will then trigger both of them to change, or all 4 of them to change in the polygon superclass, right? So we can kind of have this chain of a square is a rectangle is a polygon. And you can go nuts. You can have as many of these things as you want here. Now, at some point, it gets a little crazy, and we just lose track of it here. But inheritance is useful until it's no longer useful. That's kind of the art of how we design our solutions here. Whatever makes sense for inheriting, we'll do. And if it doesn't make sense, don't do it. That's okay. We could make another class here if it's completely separate. Not a big deal here. But all the other functions, all the other methods work perfectly fine. The same with square. So we'll have sum square equals a square. Oh, we need to import from square, right? So we'll say from square, import square. I don't think I spelled that right. It just looks wrong now. Sum square. Sum square. Yeah, I don't have my type ahead now. Set side length. Why? Am I losing it? Did I misspell it? I don't know how to spell things anymore. Square, square, square. Unresolved square. Oh, I misspelled it here too. S-Q-U-A-R-E. Square, 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 square. Okay. Sum square. S-Q-U. Okay. Sum square dot set side length. I don't know. It doesn't matter which one we pick. It should set all of them here. And again, we should be able to get the area of our square back out. My square is my sum square dot get area. Square is not a hard word. Shouldn't be a hard word. And the area of our square. Yeah. Okay. Perimeter. I was thinking perimeter. Should have been 20. No, area is 25. Okay. Yeah, we're good so far. Okay, so we can have classes that inherit from classes that inherit from as far as we want to get here with our inheritance here. This idea of object-oriented programming. We make classes. If we want a special version of them, great. What's great about object-oriented programming is eventually you'll write code that's useful. Let's be honest, we're just kind of playing around here, just doing silly little things. But eventually you write code that's useful and people are going to want to keep it around because developers, in terms of how much it costs to get people to write code, costs a lot of money. We're not cheap commodity people, right? So if you're going to pay someone as an organization to write some code for you, you want to get a lot of value out of it because it costs a lot of money to put into it, right? So you're generally automating some kind of process or doing some sort of analysis, whatever it happens to be. You want to keep that code around, and the longer you keep the code around, the more value you get out of that investment. So if I paid someone for a week of their time to write some software for me, and I use that piece of software for a month and then throw it away, probably not all that great. But if I use that piece of software for a year, I got a whole lot more return on my investment for them writing it, right? So what happens is eventually things change because businesses adapt and change and things in the world change, and we need to go and update that software. So then we'll have to go and update it. And maybe we can make a couple tweaks and we're good. Or maybe we need to do something completely new or we need to modify it. But maybe I have this Polygon class and I can't just go change Polygon because we use it so many other places now. It was such a great piece of code that we use it in 50 different processes throughout the organization. I don't want to go change Polygon, but I need a special kind of it here for one special case. So I might go inherit from Polygon to do that special thing, right? So we can take advantage of the reusability of code. You know, that's what the textbook gets into, these ideas of why we do object-oriented programming, right? It's reusable. And my other favorite reason for object-oriented programming is because it makes more sense to people. The way that we interact with the world is we understand things as objects, right? We have a bunch of different desks. Desks have a number of legs. Desks have a color. Desks have a material that they're made out of. But you could have different instances of desk, right? So when I interact with them and I use them in my code, it's sort of that human way of saying, okay, here's this instance, this is the one I'm talking about, I'll set some attributes on it. And then I'll make another one over here, and I'll make another one over here. So it is reusable, and it is more of a natural way for people to work with code because we understand things as objects. That's just sort of how our brains work, because that's how the world is for us. We like to classify things and group them up and then say, okay, this is a tree, this is another type of tree, but they're all trees. They all share these common characteristics. I probably blame biology class. The sciences like to classify things, which is fine. It works out okay. So we can group things together in classes, set their attributes, and then if we need special behavior, we go change the behavior. Say, hey, this thing that you did here doesn't really work for me. I needed to do something else. And PyCharm even tells us, hey, it's overriding. We get this cool little icon here saying, hey, it does something different than your parent class does. just fine. Like, and it's a helpful hint here. Now, if you typo something, because I typo things all the time here, oops, that was wrong. Like if I did HT instead, notice I'm not getting that icon over here. It's not there, right? So it's just a helpful hint to tell you, hey, you're actually overriding. Now, other languages have some sort of encoding and it's in the syntax itself to say, hey, I want to override what my parent class does. Python just assumes we'll do the right thing. So it lets us mess up. So there's not a lot of checking around that in Python. So you do have to be careful that you're actually overriding. And that's why these icons are useful. Like, oh, okay, great. I am really doing this new thing here. Okay. How you folks feeling so far? Mostly review? Okay. Thanks for humoring me. So on Thursday, then, we'll come back. We'll get into the rest of the things we need to talk about for inheritance, and then we can talk about the first project that we're going to work on that uses inheritance, allows us to demonstrate some of these things, and have a little bit of fun with it. That sound like a good plan? Okay. All right. I'm about out of energy for the day. I have to go find. I'm not supposed to drink carbonated beverages or caffeinated beverages, and I'm so sad. I drank coffee anyway because I needed some coffee. So I will just go and feel bad about myself and then go have my night class. It'll be a lot of fun. All right, so you folks take care. I will see you on Thursday then. And if you have any questions about lab, let me know. They're not due until the week after 11:59 p.m. Try not to get behind on them though, right? Life happens, I get it, but ideally we get the labs done in that week and we can do the next lab the next week because our format's going to follow, right? Like next Tuesday we'll have a lab on object-oriented programming, and then we're moving on to the next topic, and then we'll have our lab on it, and we'll move to the next topic. So if you get too far behind, like you're 2 weeks behind on lab, and it just makes life rough. So we should be in pretty good shape if we can keep up. Okay. All right, folks, take care.